New chapter, chapter 16, oxidation and reduction. Some definitions. I skipped section 16.1. I don't remember what is in there. It's interesting, but I'm not going to test you on it. One definition of oxidation is the gaining of oxygen. This is the definition that makes sense with the word. Oxidation, we're giving it oxygen, right? So if we look at the oxidation of iron. Iron plus oxygen gives us iron 3 oxide, also known as rust. You can also have rapid oxidation. We typically call this combustion or burning. So methane, natural gas, reacts with oxygen to form carbon dioxide and water. Here the carbon had no oxygen. Now the carbon has oxygen bonded to it. Here the iron had no oxygen, and now the iron is with oxygen. That's oxidation. It can be fast or it can be slow. Reduction is the opposite. So it's the loss of oxygen. But redox reactions don't always involve oxygen. And so then those definitions don't help us all the time. You can have a reaction between lithium and oxygen to form lithium oxide, but you can have a very similar reaction between lithium and chlorine to form lithium chloride. This is also an oxidation reduction reaction, but it doesn't involve oxygen. So in Li2O, that's an ionic compound, right? A metal and a nonmetal. What's the charge on the lithium ion there? Lithium's in group 1A. It has what charge? +1. So there's +1, and the oxygen is 2-. What charge does the lithium have over here? It's all by itself. It has no charge. No charge. Look down here. Again, we have lithium as a metal, no charge, and lithium chloride. Li plus, Cl minus. So what's happening is that lithium is losing an electron. For lithium to go from an atom to a lithium plus ion, it has to lose an electron. This is an oxidation reaction. Oxidation is the loss of electrons. Here, lithium is doing the same thing that it did up here. It's losing an electron. This is also an oxidation reaction. It just so happens that chlorine is involved instead of oxygen. So the original definition of oxidation was the gaining of oxygen. But now we've recognized that this pattern happens with other things as well. So oxidation is the loss of electrons. Reduction is the gain of electrons. Oxidation and reduction have to occur together. There is no electron bank. There is no electron rescue where you can dump off your unwanted electrons. You have to give them to someone else. And the only way to get electrons is to take them from another atom. So if there's an oxidation, there's a corresponding reduction. It's just the transfer of electrons back and forth. Oh, there's oil rig. Okay, I'll wait till I get there. So if we look at this reaction, here we've got hydrogen and oxygen, and we see that the hydrogen is gaining oxygen, right? So the hydrogen is being oxidized, and the oxygen is being reduced. So as if all of that wasn't confusing enough, the hydrogen is oxidized. That makes it the reducing agent. So a reducing agent causes the reduction of another substance. So let's talk about Hollywood. Does a movie agent star in movies? No. What does the movie agent do? He gets jobs for the actors. So the movie agent, your agent doesn't star in the movies, you star in the movies. But he's the one that makes that happen for you. The reducing agent is not reduced. He causes something else to be reduced. The oxidizing agent causes something else He's the agent for oxidation, but he doesn't get oxidized. So the oxidizing agent causes the oxidation of something else. And I know that's very confusing, and I'm sorry. I wish I could make it go away, but it's there.
Is it usually oxygen that's oxidized?
Oxygen cannot be oxidized in this sense of gaining oxygen. Okay, so overview here. So here's a good way to remember what's going on here. Oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. I have a hard time keeping these straight myself. And so if I'm looking at something as like, is that oxidation or reduction? I'll say oil rig in my head. Oxidation is loss. Okay, I've got it. So oil rig. Oxidation is the loss of electrons. Reduction is the gain of electrons. An oxidizing agent is the substance being reduced. The oxidizing agent causes the other thing to get oxidized. It's the agent. The reducing agent is the substance that's oxidized. It causes the other thing to be reduced. Okay, so let's try this. Identify the substance being oxidized and the substance being reduced in each reaction. So here we have a reaction between two elements, right? We have potassium and we have chlorine. So both of those have no charge. We're making an ionic compound. We can predict the charges of the ions in that compound. So we've got potassium and we've got chloride. And we can look on the periodic table and see that here potassium has a +1 charge, chloride has a -1 charge. Over here we just had K. You put a 0 up there if it helps you. And Cl with a 0 charge, no charge. So how does potassium get from no charge to a positive charge? Does it lose an electron or gain an electron? If it gains an electron, electrons have negative charges. So if we add a negative charge to it, it'll be negative, not positive. So the metal loses an electron. Oxidation is loss of electrons. So this is oxidized. That's the thing that gets oxidized. Reduction is gain of electrons. The chlorine went from a 0 charge to a -1 charge. It gained an electron. So it's the thing being reduced. Okay, any questions? We're looking for electrons moving around. Let's look at this one. This one's easier to see. Here we have aluminum as an element. What's its charge? 0. Over here we have aluminum with a 3+ charge. How did it get to be +3? It lost 3 electrons. Oxidation is loss of electrons. So this guy is being oxidized. There better be somebody else who's being reduced. Here we have tin, 2+ going to tin with no charge. How does it get rid of this +2 charge? It gains 2 electrons, right? Reduction is gain, oil rig. So this is being reduced. How about these two? Well, this is not an ionic compound. What do we do? Oxidation is gain of oxygen, right? Well, the oxygen isn't really gaining itself, but is the carbon being combined with more oxygen? Yeah. So we're going to say that the carbon is being oxidized And then something's got to be reduced. It's going to be the oxygen. This is kind of tricky because we're teaching you just enough to do some of it, but we're not explaining all the rest of the stuff. We explain the rest of the stuff in Chem 1A and 3 and 1B. Any questions? Same chemical equations, different question. Identify the oxidizing agent and the reducing agent. Well, potassium went from 0 to a +1 charge, right? So it lost an electron. Oxidation is loss of electrons. So this got oxidized. That means the other one is the agent, the oxidizing agent. So this is the oxidizing agent because it caused the other one to be oxidized. Chlorine's going from 0 to -1. It's gaining electrons. Reduction is gain of electrons. This was the oxidizing agent. It is being reduced. This other guy is the one that's reducing that one. He's the reducing agent. This is not the most important thing in this class, okay? So you can still pass the class if you're like, wow, this is just craziness. So here, which one is the oxidizing agent? The oxidizing agent gets reduced. It causes the other one to get oxidized. So aluminum is losing electrons. OIL, oxidation is loss of electrons, so that's being oxidized. So it can't be the oxidizing agent. This must be the reducing agent, and this is the oxidizing agent. I know, it's all circular and crazy, isn't it? This gets oxidized, it loses electrons. That makes it the reducing agent. Because this other one was reduced. Okay? The agent does stuff for something else. It doesn't do it for itself. And then down here, we talked about the carbon was oxidized because it combined with oxygen. If carbon is oxidized, what kind of an agent must it be? The opposite, reducing agent. I know, right? Give it a shot. Okay, just give it a shot, that's all I ask.